Hello everyone, we are Jinghe Technology, and today we will continue to introduce the programming of screw machines. The previous video introduced the torque of the screw machine and the torque percentage of the second stage. First set the torque to 30, then gradually increase or decrease the torque according to the actual tightening condition of the screw. For PCB products of thinner gauge, initially set the torque percentage for the second stage to 60%. Subsequently, after assessing the actual conditions, proceed to either increase or decrease the percentage accordingly. This configuration is primarily designed to prevent damage to the PCB threads, as they are susceptible to wearing following repeated tightening during debugging. Subsequently, secure the PCB. If we adjust the PCB width dimension, we loosen these screws. The method of adjustment involves clamping the PCB appropriately, but it must not be clamped too tightly. However, it must not be too loose either, as excessive slack will cause the machine to lift the PCB board upwards. After the nozzle assembly screws are tightened, there will be an upward lifting action. A slight clamping force on the PCB side is sufficient, as there is an additional clamping cylinder positioned behind the PCB. If the PCB is clamped too tightly, it becomes inconvenient for us to remove it. This way makes it just right and easy to remove. A support plate is placed under this PCB. The main function of this support plate is to prevent the PCB from shaking when assembling the screws. After the screw assembly is completed, we usually extract the LED module plastic base directly. We used to create a notch here to facilitate easy removal, but the client requires that our fingers must not touch the screen. Okay, let's continue programming and set the coordinates of each screw hole position. When setting the screw hole coordinates, we need to return the X and Y axes of the machine to the origin position. First, let us explain how to start up the screw machine and return it to its home position. Power it on first. Turn on the power switch. The operation handle will prompt to return to the original point. Return to origin. Press this to go back to the origin. Or press the reset button on the machine. The handle operation is the same as the machine operation, and the reset button of the handle is this. We press this to reset back to the origin. This is the emergency switch. If we press the emergency switch, it will show emergency stop here. Suppose the emergency switch is pressed whilst the power is disconnected. Upon restoring power, the screen remains blank or the alarm sounds continuously. You see, the operation handle prompts that we need to go back to the original point. We pressed the reset button and there was no response because we didn't release the emergency stop button. Press the emergency switch in the case of power failure. If power is restored, the operating handle will sound an alarm. The handle prompts to return to the origin. If the emergency stop is not released, there is no response when pressing the screw to reset the machine. We release the emergency switch. Then press the reset button on the machine. We move the cursor up and place it under servo configuration. This is up and down. We move the cursor to the 0001 position. Then look for the screw coordinates. These X, Y, and Z are direction movement keys. This controls the movement speed of X, Y, Z. This controls the speed of movement. This shows how fast or slow the speed is. We moved the CCD camera to find the coordinate position of the screw hole. We first switch the speed to medium or low speed to move. Move the CCD camera via the X, Y direction keys and we use the CCD camera to find the coordinates of the screw holes. Place the LED module plastic based on top of the PCB for easier viewing. The screw hole is immediately moved to the red cursor position. We switch the speed of movement to low speed. It's almost nearby. Switch this speed to slow. This screw hole should be moved to the center of the red cross. Like this, move to the center. After the screw hole is moved to the center position, we need to enter this coordinate. We press this button and a coordinate is inserted into the handle. You see, insert a coordinate here. Press once to insert a coordinate. Then cut the movement speed to fast and look for the next screw hole. When about to reach the screw hole, switch the speed to slow. Move over slowly. When you reach the center position, press the coordinate key to insert a coordinate. This will have the coordinates of the two screw holes. Other screw hole coordinates also use the same approach. We move the X, Y keys to find the coordinate position of the next screw hole. In the same way, we need to insert all the screw hole coordinates into the handle. We can also copy all the screw hole coordinates of the LED module on the left to the LED module on the right. But we first insert all the screw hole coordinates of the LED module on the left into the handle. To insert coordinates, move the X and Y axes. Move the screw hole to the center of the red cursor, and then click the coordinate key to insert the coordinates. Now we need to insert all the screw hole coordinates into the handle. Operation steps: move the X or Y axis to find the screw hole, and when it is about to reach the slow speed, press the coordinate insert key to insert the current screw hole coordinates. We must move the screw hole to the center of the red cursor. We can check the direction of finger movement and whether the operation steps are consistent. One more thing to keep in mind is that you don't press the Z-axis when you're moving. The higher the Z-axis safe height value, the higher the Z-axis moves. Due to the excessive number of coordinates, today's video ends here. If you have any questions you don't understand, you can contact us at any time. Contact information: jinghe.com.